Hello everyone. Welcome to the EasyPower Thursday webinar series. I'm your host for today's session. My name is Jim Chastain, and I have a very interesting topic for today that's drawing a lot of attention: multiple circles. And as we're in the habit of doing, we'd like to run a few poll questions and appreciate your participation. First poll question is, what is the typical communication? How do you refer to the typical communications of a digital substation? Normally we have a choice of don't know, and so you're encouraged to make a choice whether you know it or not. We appreciate your candor. There's no liability and no obligation for a wrong guess. So let's leave this open for about another 10 seconds. We appreciate the late arrivals. All right, looks like we have a quorum. Here's how folks have weighed in on this one. So there seems to be a majority opinion. Well, I would have chosen I don't know, so well, you guys are on your own. So the next question is, when designing a PMS HMI system, what could be used, what could you use the HMI PMS system for? So this is even more puzzling because we give you multiple choices and the fast readers go for all the above. Don't listen to me. just a voice over here on the side. We do appreciate your participation. For all who attend today, there will be a attendance certificate out that can be used to substantiate extended credit units. All right, looks like we have a quorum. Here's how folks have weighed in on this. All right, good. And then finally, in digital substations designed using the IEC 61850 standard, the communications could include, let's see what you think about this one. Now the good news is all of these questions will be answered as we get into the presentation. So for those of you that are new to the topic, keep your pencils close. We will provide, when the video is linked on the website, we will provide a PDF copy of the slides so you can download them afterwards. All right, looks like we have a quorum. Here's how folks have weighed in on this question. All right. So substation and electrical grid digitalization is one of the major changes in turning distribution network data into information. Digitalization is seen in several applications and segments, such as power utilities, renewables, and industries infrastructure. Our guest speaker today is the ABB Business Development Manager with over 20 years experience in power systems and is expert in implementing digitalization in electrical grids and system networks. So without further ado, let me hand the podium over to Mr. Yacine Mallem. Yacine, you have the control.
Thank you very much, Jim. Appreciate your introduction. And good afternoon, everybody. Good morning or good evening, depending what time zone you're in. We do appreciate you for this session that you joined us. Hopefully this topic will be beneficial to you and to your also organization. And hopefully this is also what you're dealing with daily. On today's topic, we're going to be talking about the common applications and design when you're doing actual digitalization of a network. And when I say digitalization of a network, could be substation applications, an actual substation you're trying to digitalize, or maybe a building. It could be you're trying to digitalize a building by changing all those analog devices to digital, and then you put your BMS system. Could be anything that a network that you're trying to digitalize. There will be a lot of process going through that. And after that, I'll show a typical schematic, or I would say design architecture of a typical system when you're trying to do a digitalization of a network. And then hopefully you'll also enjoy the live demo that we will show you after the slides when we go through. Again, my name is Yacine Mallem. I've been with ABB for a while, over 15 years. Typically, our team is responsible for digitalization of grids. We do digital systems. We take all those digitalization of products. It could be ABB or non-ABB products, and we put them in the system, and hopefully it will meet the application, depending on the customer requirement or maybe specification. So we're located in Lake Mary, Florida, and the other team was same team that we have located in Pittsburgh, Pennsylvania. So without any further ado, so right here, we will be talking about two types of grid modernization. When you use now trying to digitalize a system, if you remember now, I just used the word grid modernization. That typically also means something similar to digitalization of a grid. If you remember a long time ago, the whole thing started as smart grid a long time ago. And then we merged to new projects that start to being called grid modernization. And nowadays we refer to those, let's say new projects or brownfield or greenfield as a digitalization of a network. So what I'm showing you here, there is two lines, and this slide is busy for a reason, because when you start doing a digitalization of a grid, you're dealing with two types of projects. And I'm sure you're going the same thing like what we are going through. So typically you'll have a brownfield and a greenfield. So if you look at the bottom here of my slide, you will see here, this is the easy way. This is life is good, as we call it. You have everything digitalized greenfield. You have a brand new substation or maybe a brand new building. You're trying to put everything a digitalized network. So within the substation, for example, you'll put your digital gear. You will have your real estate big enough so you don't have to worry about the real estate, how you're going to fit all these products, digitalized products. You will all be also thinking about maybe using some special breakers, outdoor breakers, for example, if you're not going with an enclosed switch gear. You'll be also thinking about having communication, what type of communication you're going to have, the type of devices that they're required for that substation. And the whole thing here on the greenfield, it's really, it will be easier to start with those projects, obviously, we all know. But here's the challenge. When you start thinking about on the top here, brownfield, the brownfield projects are actually very, very common. I would say more than the greenfield. I would say maybe 70% of the projects within the US, either they're trying to take the brownfield, let's say panel, existing panel, and trying to, I'm giving just an example of a gear, and you're trying to patch it and make all those devices that I'm showing to become going from analog to digital. For example, maybe EM relays to digital relays, maybe analog meters to digital meters. Maybe you're also upgrading your protection. You're making digitalization of protection. Maybe you're also adding redundancy of communication. At the same time, you're thinking maybe I'm going to have to lay down some fiber. If you see here on the right-hand side, you're thinking about using some switches. Those switches are high-level switches, managed switches or smart switches, as they call them. So you're thinking about all this in parallel. At the same time, you're thinking about also the real estate. Do I have the real estate that I need to put all those devices? How am I going to do all those devices, put them in existing panel? And how do I manage also my outages? Because you remember, you cannot just shut down the power and work on it until whenever you are done. You have to keep in mind, maybe you work feeder by feeder, depending on the utility or the end user, how they're going to allow you to do that. And at the same time, you're thinking about other stuff, meaning protection, communication. You're thinking about fiber laid down on the substation. That's a given. Within the substation, typically, that's the best solution you will have. Maybe you're also thinking about upgrading your PLCs. Existing PLCs nowadays on the brownfield substations, you will see them as analog. And now we're talking about digital, for example, digital PLCs. Maybe you're thinking about also doing a soft communication PLC. You could utilize in nowadays the digital relays. Digital relays can do for you now some PLCs. You could have maybe, for example, you're thinking of doing an ATS scheme using the relay instead of having an outside device. So there is many things you're going to start thinking about when you start doing this brownfield projects, and you're thinking about is usually there is a team that will get together in the room. Hopefully, if you are maybe the consulting to an end user, you will bring those guys together, communication engineers, protection engineers, Alignment also, don't forget, those guys are very useful also. They are the ones dealing with day-to-day a job that they are going through. They'll give you some good insight and good tips. So you're looking here at the same time, I'm doing all this digitalization, and then once you're done, you're gonna say, okay, I have all this now fancy substation, for example. How do I pull that data? What do I need? The type of HMI I'm gonna need, and if my HMI, or let's say we call it a power monitoring system at the substation level, how do I pull that data, and how do I also design that HMI in such a way I will pull all this data from every single device, and how do I manage all those signals? What type of hardware I'm gonna need to do that? What type of software I will need? The licenses I will need, and where do I store that information once I have it at the substation level? So you will see here, looking at this step by step, you're dealing at the major applications that they are actually separate from each other, but you got to put them together because you're acting as digital system where you take all this information, all those devices, make them talk to each other. You pull in data of the HMI. At the same time, there is PLC running in the substation. Maybe there is an ATS scheme running in the protection, and you have merging units, for example. At the same time, you need to think about safety of your staff. Once you're doing all this digitalization, how do I make it safe for my staff when they are exposed to the gear? Maybe the best way to do it is don't have them exposed to the gear. In our days, really, there is no need for somebody to go and pull information, for example, from a relay face-to-face to the gear, where you could do that remotely, or maybe run a wire to a control room and do it through an HMI. So there is many ways of doing this. And also you can think about maybe all this data that is important to you that is running in the substation or substations. You need to do something without it because your server hardware in the substation will get filled up, right? So you need to think maybe of doing from the edge, as we call ourselves here, on the edge substation. You need to pull it maybe to a cloud if you want to do that type of application. And at the same time, your cloud will be running maybe your asset management. You'll do all that, and it's pulling data from the two systems, right? Maybe also you are doing that at the gate, at the edge level, which is the substation. Maybe you have a SCADA system also you need to connect to, right? So remember, you are thinking many applications at the same time. And also at the same time, when you're doing this, you're thinking about what is required today and how I'm going to fill up the whole project in 2 years, 3 years, 5 years, whatever the window will be. Because you could be starting with a small substation. Maybe in 2 years, that substation will become a huge substation, 3 years or so. Maybe that's one substation number one. You're going to add another substation number two. So you got to think about the two, how they're going to work together in parallel and have all that communicated to one site that you could monitor both substations. At the same time, in our days also, we're adding IP cameras. We talked about the safety of the staff, right? So in our days, if something happened when the HMI, which I will show you a demo, when you have a destabilized system, typically you don't want to send your stuff right away and see what you have technology in our days where you could have IP cameras to see what happened at the site or maybe the substation to make sure it's safe for them to go there and do whatever it needs to be to restore your system. So you can see here when we start thinking about a spec or requirement, starting thinking about all those devices, how do I make all those devices talk to each other? What type of protocols I'm going to be using, depending obviously on the data. Maybe you have upstream and downstream protocols that you need to comply with. All that has to be in consideration when you're doing actually your design of that grid digitalization that you're doing. So it is a big task. So typically there is a lot of team, a big team that is working on this at the same time. Now let's move to this one here. So you could see here, I'm showing you actual an example of a grid. So you're here, we were talking about the substation itself within this substation. So finally you did, let's say, all your digitalization of your product. You have this fancy digitalized product. You did your ATS scheme. You did your PLC upgrade. You have all this communication laid down fiber. You have your Ethernet switches. Depending obviously of your protocol, your Ethernet switches are very critical, which one you're going to pick. So look for example, let's say you have we think about using 6150 in the substation. And by the way, the 6150 now in our days in the US is being very actually used, more common than usual. Because before the 6150, you could hardly hear about the standard. So when we talk about 6150, it is a standard, but within the standard, there is 3 ways of communicating. I'll just give you a little bit of a hint here. So you get goose messaging between the devices. You have simple values, which is based on the 9-LE simple values. And also you have MMS. So the MMS typically is for your HMI or SCADA system. So you got to think about this. When you're designing a system, if you have an existing, for example, upstream SCADA, you need to make sure that protocol, usually you're going to connect through maybe, for example, an OPC UA, you will connect to that system. So your system becomes a gateway to that system, right? Sometimes maybe you're doing, let's say, some logic in your HMI. It's not only an HMI, it's also, let's say, a data concentrator. It could be an automation controller. It could be anything that you're doing with it. And I will go through those one by one. So you could see here, once you're done with your substation, the job is not done because you're outside the fence, outside your substation. It's a big grid that you still have to utilize all these devices. You need to upgrade them. And maybe you could still utilize other protocols. I'm showing here Modbus TCP, for example. DNP3, it's still widely used in US outside the fence, right? So you need to make sure that also you comply with that protocol if it's still used on the poles. So once you do that, you have all this grid that I'm showing you here. All those devices have been upgraded. They meet the spec of digitalization of the network. Now, what do I do? How do I pull all this data from the substation outside the fence? And you look at it as a whole puzzle, right? So you're pulling this data to bring it to an NCC room or SCADA or control room, and that data will turn to information. So the whole thing, the whole goal at the end of the day is you have a sustainable network, reliable network, and also you have less outages. You could make decisions based on the data you're getting, which is usually real data, live data, sent from your substation and other sites to your main control room, and then you will take a decision based on that. So once you do all that, here's the question that comes up. How do I pull that data? What kind of devices do I use to bring that data? And I'm talking about remote access communication devices. So probably most of you are familiar with the 900 megahertz radios, the 2.4, the 5, the 4, and so on. But in nowadays, also, when you start talking about digitalization, you will see communication specs section. They're referring to 5G, 4G, and LTE routers, which is widely used not now in the spec. And the reason why they are jumping into that technology, and they will be signing up with, for example, AT&T, Verizon, or T-Mobile, whoever is the one is going to sign up with that end user, because it is cheaper to implement. They don't have to build for them, let's say, repeaters and access point and endpoint, and you start going out in the middle of rural areas. And so it's going to be very expensive for you to build the infrastructure to pull that data. So you could see here, there is some devices called LTE that I'm using here in my digitalization of network. That could be very helpful also if you want to pull some data from AMI, from reclosers there away from the grid, and so on, pull them backdoor to the main office through an LTE signal, for example, or a 4G. So typical communication, when you start thinking about it, now you could see already, we are not talking about devices, we're talking about remote access communication. I need something that brings that information to me, to far away. Could be 3 miles, could be 4 miles, could be 300 miles. So you're looking at a bigger picture now. So once you do all that, typically in a congested area like this, you will be using a Wi-Fi mesh type of application communication solution. What I mean by that, for example, I'm sitting in Lake Mary. So it's a small area in Florida. You could use within the city itself, mesh wireless maybe solution. And then when you start going out on, for example, you start hitting your suburban rural area, you're going to start using maybe your LTE and so on. So you could see here, I need this data from other spots also from my grid. So you got to look at the bigger picture. So you could see here, I'm showing you 3 main protocols, 6.15 in the substation, DNP3 outside the fence, Modbus TCP, for example, and so on. So all these communication protocols have a limitation if depending on the data you're pulling. So I hope this the bigger picture that you're seeing, it is more toward than just putting digital products or digital devices, and then The puzzle is how to make them work together to fulfill that specific application that you're trying to achieve. It could be a spec, or you could be acting as a consultant to whoever is your customer or the end user. So now let's move to this interesting topic. So once I did all that, let's say all this digitalization, right? I put all my hardware there. Everything is brand new. All it's digitalized. I have digitalized mirrors, digitalized protection, digitalized communication. I have fancy switches. Like I said, typically they are the high end that will support 6150, for example, if you're using 6150 standard. Maybe you're doing redundancy of communication, maybe PRP, HSR. So those are special switches. And I will show you in the following slides how it looks when they're all implemented together. So when you start now, you're done. They come to you as an HMI or power management system or power monitoring system or a SCADA design. They want you to do SCADA for them. You need to start asking questions. If they have specification requirements, it's good. Take a look at it. Maybe you could give them some advice if you see something that doesn't seem right, right? Maybe they have a single line diagram already for you. Here's my single line diagram. Please make it an HMI for me. Again, going back to my greenfield and brownfield topic. Is it greenfield or brownfield? Again, you need to know that. Because once you implement your HMI, maybe you're going to keep some of the old protocols or maybe another network they don't want you to touch. However, they want you to pull data from that network in parallel with, for example, your 6150 brand new network that you built for them. And I'll show you that in a second, how the two networks work together if you have a case like that. And then you're going to start asking yourself, is the power monitoring system that I'm putting in the substation, is it going to act as a substation HMI, meaning locally? Do we have any web clients that will pull that, that information to their laptop, for example, maybe on site there, far away, 200 feet from them? Or maybe is it some information that I need to pull far away? Is my system going to be a gateway to another system? What I mean by that is maybe there is existing SCADA system that they already have, and they want your system to act as a, for example, a mini SCADA to their system. So they're pulling data from your system, and you give them that signal. All those signals go into their system through, for example, OPC UA, like I mentioned earlier, or some type of connection that you do for them. Maybe your HMI also not only is acting as an HMI, maybe it's also acting as an automation controller. Typically, we'll try to stay away from that. When you do this kind of a digitalization of a network, you want your outside logic, your outside controllers, PLCs, anything automated need to be an external device. Leave the HMI alone. It will pull that data, but everything else is working in separate in different devices. That's at least, my tips to you guys. Maybe it could be local or main SCADA, like I said. Maybe they don't have a SCADA. They want your system to be not only local, it can also act as a SCADA in somewhere for them. So you need to, duplicate that to them to a bigger software where you pull, for example, substation 1, 2, 3, 4, and the main one will be on top of them, and you're pulling data from all those 5 sites. So again, you need to ask yourself, how many devices do I have to monitor? What kind of devices they are? What type of communication protocol they have? When now we're talking about the digitalization of a system, typically you want to stick with the TCP IP type of Ethernet preferred. This is easy to engineer and easy to connect to. So any meter nowadays, when you say digital meter, it will have an RJ45 port, and you're pulling from that port directly. So that's at least one thing. You need to know also is that system is going to grow in the future. I'm starting with 10 devices, 15 devices, maybe in 1 year, 2 years, 3 years, that will be 300 devices. So what you need to do then, you need to make sure you give them the right licensing from day one and also the right hardware. So you don't want to lose your face with the end user again, tell them, hey, by the way, if you need that, then I need to charge you more licensing and it's going to be more money for them. They will not appreciate that. You need to give them heads up ahead of time. So you give them the right tags. I'm using the word tags and the word signal at the same time. So for example, if you pull a system that has 10 devices, for example, so you are using, let's say, 1500 tag. Remember, one tag is equal to one signal. So you take those 1500 divided by 10. So you will see there, I have about, I will have about let's say 150 signals for each device. Remember, devices are not equal. What I mean by that, one device can pull 20 signals maybe, the other one can pull 30, 40, 50, maybe 100 signals from it. So you need to do this equation depending on their plans on the future. If they tell you our substation is going to grow from 1 substation to 5 substations, total will be 300, 400 devices from day one. Just give them either 7,000 tags or unlimited tags. So I'm just trying to, you got to have that conversation from day one when you're designing a system. Okay, now let's go back to our real estate. We don't have maybe space for such a system. You need to make sure that, if they don't have space, you have to build some solution for them to have this HMI and all these Ethernet switches in enclosure or maybe control cabinet or a rack. So this way they will run the wires to the gears and so on, because they don't have space in the cubicles. It's all taken. So again, you need to start having this conversation. This is a few bullets that we put there just to start the conversation with them, and then you know how to design your system. Now, let's talk about the hardware and software. Typically, the hardware will have a limitation. So that's why we need to know what type of a network, how big of a network, and you need to know. So the minimum, I'm just showing you here as an example, the minimum system that you run as a simple system is what you see here on the screen. So the CPU has certain limitation. The RAM memory has to be minimum 4 gig, for example, and up and so on. So these are really the minimum of a hardware selection that you're going to be picking to run this type of software. Now, when we talk about the software, you need to call also about the protocol communications. Some systems can handle over 300 protocols, but you need to know what protocols do I have. If you have all those devices, if they are okay with the 6150, they can support it, you're good, use that. For example, if they are relays, if they have, let's say, some Modbus, try to pick, instead of serial, pick Modbus TCP, for example. DNP3 as well, do the same thing, and so on. So here, and then you'll see, okay, I have my system, I need to upgrade it to connect it to another system. Now we're talking about an OPC UA type of communication. How is the system connectivity from the server using the process? For example, maybe a gateway process if it's an industrial customer, or maybe it's just another system, SCADA, that you need to to fulfill and comply with the protocol they are using in order for them to tap your system. So you see here, the software does not have a limitation. We have to concentrate more on the server hardware. The server hardware typically will have a limitation depending how big is your network. So you start here thinking about the system. Again, here, this is just to show you here, if I don't have space in my gear, there is no real estate for me there to put all this stuff. You could build something like this for them, where you will have, for example, the local HMI here, and you have your PC hardware of the actual power monitoring system. You have your Ethernet switches. If they don't have space in the gear, you could put them there, and then you run the wires. And you have probably either touchscreen if you want. All that can be done depending on the preference of the end user. Maybe they don't have space also for certain relays. They want you to put some relays on your control cabinet. You need to also, plan for that as well. So you could see here each control cabinet depending really of the requirements and what situation you're in. It could be just an HMI, SCADA monitoring system, or it has also other devices with it because you don't have space in the cubicle depending on the requirements. So now let's see just an example here. What type of a system do I have when you start designing a system? You remember, this is the horizontal communication. I'm using, in this case, 6150, right? So 6150 standards, I have 3 ways of talking within that standard. For example, here between the devices, I'm using goose messaging, right? So your goose messaging, for those who don't know what is, generic object-oriented substation event, which we refer to it as a goose. That is part of the typically used with an RJ45 from device to another, and the goose message will be going back and forth from devices. That's one way of doing it. Maybe you're also using, you have some merging units. Maybe you have to use sample values, right? Instead of having a relay here, maybe I have a merging unit that is compliant with 6150 standard, and it can support the 9-LE sample values. I could do that. And then when you get to the HMI itself, I'm using MMS. So that's another way of doing it. So at the same time, you remember, you have those Ethernet switches. Those Ethernet switches, they need to support 6150 standard. They also need to support PRP HSR if you are doing redundancy of communication. At the same time here, I'm showing you another network, could be here a 480 level, right, low voltage. And I'm tagging in also the MCC or maybe some low voltage breakers and so on. bringing that signal to another Ethernet switch, and then medium voltage, low voltage. Remember, I'm an HMI. I don't care about the voltage. I can be a player on both sides, and I pull that to the main power monitoring system, and then to my control room and so on. Maybe you also have some analog inputs that they want you to also monitor. So in that case, you will have to use maybe a device that will change analog to digital inputs, and you just dump an RJ45 in the main hub of the Ethernet switches. So this is just an example, and it's a typical example on a normal standard network that you're trying to digitalize. So you could see here, having all this configured, engineered, you have to engineer the Ethernet switches, you have to engineer the protection, you have to engineer the communication. It's a lot of work you have to do here. And then once you're done with that, you have your HMI that comes at the end, and then you pull all those signals to the main office or the main NCC room. So let's look at where you have an example of two different networks, right? I have two different networks. I have maybe brownfield, customer and user don't want to touch it, leave it alone. I'm happy with it. Modbus TCP, it's running there. You have your Ethernet switch. In parallel, you have another system. This is the greenfield one that I just put for them. It has 6.50. It has the digital relays. It has everything that they wanted there. And now both of them need to be monitored. So I could bring that to my Ethernet switch. Remember, this is my smart Ethernet switch. Both sides, both networks, depending on the network, what they are using, and you will be monitoring that system either at the level of the substation. You could build for them maybe this type of a rack, or maybe then you need to move that information to an ACC room, or maybe there is a control room not far from the substation. So that's typically how you do it. So you could see here, we are flexible as far as designing a network. You could do digitalized one with the normal one, and then you put them together, talking together. Could be maybe substation 2, substation 1, two different protocols. You bring both of them, and then I have a view at my HMI, what's going on with that system. So now you could also do, this is industrial applications, for example, where you have maybe a building that you're trying to monitor. Maybe you have a substation, and also a building that they want to also be part of digitalized project that you're doing. So flexibility is there. Remember, I'm an HMI. As long as the protocol of that device that I'm pulling the information from, it's not some exotic protocol, I can do it. So here it's a bigger picture. When you have your sub-transmission, for example, here on the left-hand side, you have your medium voltage, your low voltage, and here on the right-hand side, I'm showing you the type of devices that could be falling under that level. So here, really, when you do all this, you're already engineering the communication. Your digital devices are everywhere. Maybe you're doing an ATS scheme. Your PLC is working as well. And then you have all this network, meaning medium voltage and low voltage together combined, bring them to one site, and you have maybe, for example, server 1, server 2, server 3, and so on. And then it goes all the way to the control room, either via remote access communication. And if it's on a site, you will have obviously fiber directly to it. So you could see here just a different level of voltage. It really doesn't matter how you do it. Now, with that said, hopefully this is just for you guys to share some of the projects we've been working on US, Canada, and Mexico, and also global. We are not allowed to, because we're under NDAs, but to show you here typical projects that we have working on, the list is actually much bigger than this. So there is a lot of references within the US when you start now talking about digitalization of a substation, a grid, or a building, and so on. There is a lot of brownfield project as we speak right now. So with that said, let me now go ahead and start my demo. So for a little bit here, you're gonna see I will lose the screen for a little bit because I need to change the screen. And it's coming quickly here. Just give me 1 second. And I will switch screens to my screen number 1. Hopefully you can see it. And the demo is coming right now. So now I'm sharing with you an actual demo. Looks good. Thank you, Jim. Appreciate it for confirming it. So you could see here, this is just an example of what a system, a basic system looks like. Obviously here on the top, you could have a lot of tabs here depending on the requirement of that specific, HMI or power monitoring system that you are to build for the customer. Here I'm using some relays that I'm pulling the data from. This is just a preference. Some customers, they want to maybe change the color, change the graphics. This is just a preference. It's all cosmetics, as we call it. So the line here in 20 kV line, I have also 10 kV line on the blue. and also the green way, which is actually the green one is the 10 kV, and the 400 volt is the blue one. So you have a combination of networks, combination of a gear, and I am monitoring all these devices. So the way right now I'm doing it, I want to get some measurement from that specific gear. So at the tip of your finger, you just click there, and I'm getting some, power active, for example, reactive power, and so on. I have some current, some voltage running there. This can be custom made, obviously, depending of the customer, what they want to see on their HMI. So this is, again, it is custom made typically on what they want to see on the screen. I can also check my trend, for example. You could see here I'm doing a trend. So I'm, again, playing with the software here to show you typically how I'm gonna monitor a digitalized network or digitalized substation. Could be BMS system or a PMS system, whatever the case will be. This is an HMI for that. And the beauty about this now here, I'm trying to, right now I get into the relay without even changing the IP address and going from a different screen. I'm already in the HMI of the relay. I can already check the phasor diagram and so on from the tip of my finger right here. So typical system like this, you also need to have not only the HMI I just showed you, you also need to have a diagnostic of the system, meaning the health of the communication of my system. You could see here, everything is green. The communication is running good. I don't have anything. In a second, I will create some action. So you see how a disturbed network will look like. And then what do we do with those events, alarms, and so on. So with something like this, typically, that's a basic system. You will have your single line diagram. You will have your diagnostic of a system, meaning the health, and maybe also reporting, which I will come back to right now. So the reporting, maybe you have some relays that you need to pull some fault record from, which also I can do without even exiting my HMI. It is part of my HMI altogether. So you could see how convenient is this. You could pull directly from the HMI. I'm already right there in my contract files viewer, and I can see exactly what's going on. Also, maybe you're in to run some minor reports. Maybe something that you want to do from that time to time, you need to run some reports. So a basic system probably will have also a couple of requirements like this. So let's recap a little bit. A basic system will have single line diagram. You're also able to open and close the system. This is also a preference. Some people don't like to see this. You could see here, I just also open the breaker. I can close it back. So if the control is not required, customer doesn't want it, you don't have to have this functionality. You could always block it. So you could see here, I can do control. I can read from devices. I can check what's going on. I can run report. And at the same time, I will go ahead and create some action here. So I will show you this here, where I will actually run some communication. I will trigger some communication problems. So it's right here. You will see your 620 here relay will actually turn red. So here already my alarm is telling me, hey, there is something going on with that gear. You lost connection. So if I go back now to my screen, you will see it flashing like this on the screen. Let's go ahead and have more action here. So I will do trip some relays, for example. I will also do efficient gas pressure. Maybe I'll mess up a little bit with spring charge there. And you will see here, my system is destabilized. It's not stable. So typically this is if the operator is not looking at the screen, you will see that siren going off in the room. So they will know there is some problem in the network. Again, it could be industrial customer, could be a power utility, normal utility, and so on. So it's already telling them, hey, my system is not stable. I'm having a problem. Then you will go to your alarm page. You will see what just happened. You lost connection to the gear. You have your 51 and 51P and 50 tripped. So your breaker tripped in your feeder, motor, and generator relay. You have also here insufficient gas pressure. All this happened in your network. So you could also go ahead and acknowledge this. So they will stop blinking. But again, every end user have their own procedure how to reboot a system or restore a system. They have to go through their safety to see what's going on first. And then you can open and see exactly, here's my alarm page. So you have your alarm page, and then you can also go and check your event page. So again, this is a basic system. You need a single line diagram. You need your diagnostic of a system. You need reporting, contract files, alarm page, event page. Those are the minimum of a system that when you are monitoring a system. So you could see here what I'm doing. So you go here also again, and I can also do again, edit the users, for example. If I'm signed in as an admin, I can do a lot of damage to the network. You could limit who's doing what and what they can do onto the network. They can be viewers. They can be just doing things without touching the relays, for example, changing settings, opening the breaker. You can also add here messaging. You could send messages to your iPhone, to your cell phone, to your email, and so on. It gives you heads up what's going on. So just to recap here, this is just a system that will minimum requirements when you monitor a system. There is also a good tool here that it is included with the system that we have. This is pretend if you have here more than 300 units, 300 devices you're monitoring. This becomes very handy. You could name them by switchgear 1 or maybe substation 1, and then it will take you directly to that specific device that you're trying to see what's going on. So this is a really handy one. Not only it can limit it to the actual single line diagram, you can also use Google Map for that. It will take you to the site and it directly will take you there. For example, I'm now pinging to Florida. So it will take you to the site. From there, you will go into the single line diagram. And maybe sometimes you want to add a switchgear lineup. So this is just to recap here, this is just the minimum system requirement that typically it is necessary to build and monitor that. So again, digitalizing of a network, you just digitalized all this fancy stuff. You put all these digitalized devices. You did your applications, for example, PLCs, ATS schemes. You upgraded your protection, your meters. All that is done, and then you added IP cameras. You're doing all that. All this can be summarized in your power monitoring system. With that said, let me just go back here and go to monitor number 2. And I will go back to my slides. So that was the demo. And we can go back here again and continue with our presentation. Hopefully you guys have some Q&A. So Jim, this will conclude the presentation and the demo. Please take over and see if hopefully we have some questions.
Yeah, in the chat box, Yacine, I've posted several. Let me read them to you. And question that comes up, I guess, in my mind, how do you deal with data security? How do you deal with cyber issues?
That's a very good question. That is actually the most common thing when people go digitalized to a network. First of all, each device, digitalized device, has to comply with the NERC. That's the first thing that the device has to do. Now, once you do that, you'll have to think about it as a system. You have communication devices, you have a system put together. Typically, end users either will hire a third party, they will sniff the system for them, they will try to see how people can break through it, maybe through a GPS system, maybe through relay, through communication device, through whatever the case will be. That's the first step they need to do. And each system software will also have they have to comply with the cybersecurity. The devices we're using in our days are very, very hard to break into. For example, if you are using remote access communication, you're worried about somebody is going to hack the system. Typically, those devices are very, very hard to break into. First of all, they are not doesn't appear to the public. You cannot see them to the public. They're using some special routing. Special, for example, if you are using an AT&T SIM card, you're dealing with the grid. Those are special devices, special routing with the firewall embedded in them. And also there is point-to-point communication with the VPN. This is the same technology that there is being implemented in the grid in our days, which is new to the grid, have been used by the banks. So the banks, you could imagine, you're playing with money, ATM and all that, that's all implemented. So every single time you build a system, first you got to look at the device. Does it comply with the NERC standard for cybersecurity? Once you get out of the device, obviously you're putting all this together as a system. You need to also hire somebody to check it as a system, trying to make sure there is no perfect system, 100%, cybersecurity proof, but they try to minimize the damage and higher percentage. Let's say you hit 99.99%, your system is good. Hope that answers the question.
That was all over. Thank you. How do you configure an IED?
So I'm assuming you're talking about an IED, that's a relay.
I think
so if you're talking, yeah, so that's a relay. So typically we don't want to use those terms. We're going to be using a relay or a device. So When you mean by configure a relay, let's say it's a relay. First, you have to configure it, meaning I'm going to work the protection. So you do your protection first. You set your protection. Once you're done with the device itself, after that, you need to set your communication. So if you're talking about the relay, I need to make sure my relay is communicating to whatever Ethernet switch I'm using, or another, if you're using HMI, am I able to communicate to that HMI? So there is many ways when you say how to configure a relay. So a device or a meter or whatever device you're thinking of, there is tools in it. You configure it depending on the protection that there is required to do. Whatever protection element, you activate those. Let's say if the device itself, you are using it also to do an ATS scheme. Within the logic itself, you could build maybe Boolean algebra. You could do that on the relay as well. So you're not talking about configuration. You're talking about engineering the device. So it's going to get even further out there, depending on the spec, what they want you to do.
Right. Next questions. ComTrade version. Do you know what version of ComTrade is being utilized?
Well, it depends from the device to device. So the ComTrade viewer, typically there is only one. The latest version, I really don't know which one we're using nowadays, but typically the ComTrade files, whatever device you're pulling from that, the ComTrade file will have to be probably the latest they are using, and it's just a normal ComTrade file, viewer as they call it, and that could be pulled from the relay and then from the relay to the HMI. So it's not the HMI requirement to do that, it's just reading the relay directly, but the relay usually is giving you those ComTrade files from the relay itself.
All right. This one I don't understand the terminology. Can we have ComFeed files? COMFEDE.
ComFeed files.
Yes.
I really don't know what they mean by that. Maybe we could take it aside, this question, Jim.
Okay. Yep. Can the demonstrated system be configured to provide controls and information on traction power dynamic train operations?
So now you're talking about a system that is fully integrated. It depends on the application. The demo I showed you, it was based on utility type of application. Obviously, this is a software. It's like your C++. Once you have your editor, you could do whatever you want with it. This is the same software that can be used for, railway application, food and beverage, data center, pure power substation that I showed, anything like that. It is just an open software that you could build anything, any application that you are interested to build. Yes, the question is yes. The answer is yes.
So the question is, where can I access the presentation? When we post the video on the EasyPower website, we will have a download link for your PDF version. So that's something EasyPower will have done probably early next week. What sort of time synchronization support is rendered?
So there is many ways of doing this. So you're talking about time sync. Typically, the devices you're using will have to comply with the IEEE 1588. For example, a relay. You pick a master or a server, and it will give it to the whole system, whatever devices that we have. You remember we have those devices connecting to each other through goose messaging. You pick one to comply with the 1588. And it will do that for you, the timestamp. Another way of doing it, if you have a big system like I showed earlier with the power monitoring system, you will have some kind of a GPS clock, for example, a Tecram or one of those that will give you the actual timestamp for the system itself. So you're talking about a system now. The whole system has to be timestamped.
And it only requires one time sync source, or can you accommodate existing ones?
If it's so if you have different networks, let's say you have network number one, if whatever network they're connecting to together, one time sync will do. So you just connect it to the main hub of the Ethernet switch, and that will take care of the whole system or a network. If you have several networks, as long as they're connected together, you only use one. Just like your device, when you're doing remote access communication, I'm not going to use one device for each gear. I have my hub Ethernet switch. I dump one of those remote access communication device connected to the main hub of the Ethernet switch, And then from that, I have access to every single device that is on the network.
Yeah, good. So the question is there a budget metric to have an idea of what an overall system cost of digitalization would be?
Well, it depends how big of a network and what the requirements are. I mean, a simple network, typically if you're a digitalized system and you have, let's say, 10 to 20 devices, as long as you keep the HMI simple and there is no ATS schemes, there is no other fancy stuff, you're just pulling something, it can run you up to 50 and up. So really it depends on the network. If he's gonna start thinking about now, I'm digitalizing the system, I have to engineer the PLC, I have to engineer the protection, I have to engineer the communication, and also I have to do all this hardware and all that. Plus I have to throw in the HMI, and I have to engineer also the HMI. So this, it can get, you know, it depends of how big of a scale of a project you're talking about.
Now this one is a little bit on the fringe, but the statement or the question is, if the GPS is hacked security-wise, what will be the questionnaire? Right then, how do you ensure security for the rest of the system?
Well, that's a little bit, like they say, it's a little bit tricky one here. So I'm not a cybersecurity expert, but typically first of all, when you pick your GPS system, please don't pick the cheap ones like you buy from Amazon or whatever. That's a number one thing I would advise. Same thing with your API cameras and all that. So hopefully it's robust, it is for industry application, and it has fulfilled many cybersecurity, let's say, standard and so on. That's really, I mean, once they are into your system, I don't know how you could have maybe some layers to stop that. If maybe you trigger something, maybe something you could build in something in your system that somebody is tampering like that, just like what happened, I think a year ago or 2 years ago with the Colonial Pipeline. When they realized there was a hacker, they shut down the whole system on them, so they were not able to do damage to the system. But again, this is something that maybe it's a separate topic on hacking and cybersecurity that maybe we can talk about in other experts, I would say.
I think that's the last of our questions. Yacine, thank you very much. It was an excellent presentation.
Thank you, Jim, and thank you for the audience as well.
So long and have a good day.
Thank you.